Hello everyone, my name is Bhanwar Singh and I will be presenting you with the crash course of World Geography. In this lesson, we will study the topic of physical geography, in which the topic for this lesson will be the internal structure of the Earth. I have done BA Honours in Law from Awadh University and I am ex-NDA 115 course. I have also cleared Civil Services Examination 2012 and my hobbies include writing poetry. You may follow me on Unacademy platform by following the link that is given on the slide. As far as the internal structure of the Earth is concerned, it can be understood only with the help of indirect evidences, as no one has reached the Earth interior, which is up to 6,371 kilometers. Thus, it is almost impossible to reach the center of the Earth and collect the samples of materials. Under these conditions, our knowledge about internal structure of the Earth is based largely upon the analogies and inferences, and a part of the information is also obtained through direct observations and analysis of materials. The sources of information of internal structure of the Earth may be clubbed into two heads, that is direct sources and indirect sources. So the direct sources includes the readily available surface rocks which we get from mining areas. The mines are up to 3 to 4 kilometers deep, and going beyond this depth is not possible due to high temperatures. Besides mining, scientists are working on various other projects, and these are major projects such as Deep Ocean Drilling Project and Integrated Ocean Drilling Project. And these projects have given us a large volume of information about the interior of the Earth. Another direct source is volcanic eruption, where as and when magma comes out to the surface of the Earth, it becomes readily available for analysis, and but it is difficult to ascertain the depth of the source of such magma. So in such scenario, it is impossible to find out the exact depth from which such magma is coming out. The indirect source includes changes in temperature, pressure and density. While we go down the surface, normally the temperature increases by 1 degree Celsius for every 32 meter of depth. But this rise in temperature is not uniform. For the first 100 kilometers, the temperature rises by 12 degrees Celsius and per kilometer, and then by 2 degrees Celsius for next 300 kilometers per kilometer, and then by 1 degree Celsius per kilometer of depth. Another factor is that though density increases with increasing pressure, yet there is a critical limit of rock beyond which density cannot be increased. It shows that high density in the core is the result of its heavy material in the core. Further, the average density of the Earth that is calculated with mathematical formulas is 5.5 gram per centimeter cube, whereas the density of the Earth crust is just 3.0 gram per centimeter cube. So this indicates that inner part is denser than the crust and density of material increases with increasing depth. Meteors are another indirect source of information about interior of the Earth. However, since these are not part of the Earth and are composed of materials which are same or similar to that of the Earth, these meteors offers insight into the interior of the Earth only by analogy. Another indirect source include gravitation and magnetic field of the Earth. The gravitational force is greater at the poles and less at the equator. It also differs according to the mass of the material. So the gravity anomaly gives us information about distribution of mass of the material in the Earth's surface. The most important of all the sources, whether it may be direct or indirect sources, is the indirect source of seismology or the earthquakes. The study of seismic waves provides a complete picture of the layers of interior of the Earth. These earthquake waves are recorded by seismograph, and these waves are of three types and they travel in different manner, which we will study in another lesson. Going by, the Edward Swiss was the first geologist who explained the interior of the Earth on the basis of chemical composition. According to him, the Earth is divided into three layers. The first layer is Sial, which is the top layer of the earth, and it is made up of silica and aluminium. Si is the chemical name for silica, and Al is for aluminium. So it is made up of silica and aluminium, and its average thickness ranges between 50 to 300 kilometer, and density ranges from 2.75 to 2.90. The continents is supposed to be made up of sialic layer, which is lighter and therefore floats over the underlying layer. The second layer is the CIMA layer, which is below Sial and is made up of silica and magnesium. The density of this layer varies from 2.90 to 4.75, and it is found between 1000 kilometers to 2900 kilometers. The third layer, according to Edward Swiss, is Nife, which is the last layer found in compact state, and it is made up of nickel and ferrous. This layer extends from 2900 kilometers to the center of the earth, that is 6371 kilometers. The density of this layer ranges between 11 to 13. The structure of Earth's interior is layered, and it is broadly, there are three layers that can be identified, which are crust, mantle, and core. The crust is the outermost thin layer, which you can see here. It is the outermost layer, with a thin layer with thickness varies from 5 to 30 kilometers, and some other sources estimates its thickness to be 100 kilometers. This layer is basically formed by Sial. The outer layer of this layer is of sedimentary rocks, and below this lies crystalline, igneous, and metamorphic rocks. The crust forms 0.5% of Earth's volume, and the average density of upper crust is 2.8, while that of the lower crust is 3.0. The second layer is the mantle, which lies just below the crust up to 2900 kilometers. And it is formed mainly by basalt rock. This layer is composed of CIMA, and it forms 84% of Earth's volume. The average density of upper mantle is 4.3, and that of the lower mantle is 5.5. The core is the innermost layer of the earth that lies below mantle from 2900 kilometers to 6371 kilometers. It is composed of Nife, and it is responsible for the earth's magnetism. This layer is made up of heavy materials, which results into its high density, and the average density of outer core is 10.0, while that of the inner core is 12 to 13, and in the innermost part, that is at the depth of 6371 kilometers, the density ranges to 13.6 gram per centimeter cube. There are certain boundaries between different layers of the earth, which represents difference in physical and chemical properties of the Earth's interior. These discontinuities, as you can see here, are lined, and the first discontinuity which you will see is Conrad discontinuity, which lies between the outer crust and the inner crust. That is, in mid of the crust lies the Conrad discontinuity. Then we have the Mohorovičić discontinuity that lies between the crust and upper mantle. And then we have the Ripety discontinuity, which lies between upper mantle and lower mantle, and Wiechert-Gutenberg discontinuity, which lies between the mantle and the core, or between the lower mantle and the outer core. And then last we have the Lehman discontinuity, which lies between the core, that is between the outer core and the inner core. We all know that Earth has magnetic field of its own. The magnetic field is produced by motion of electrical charges. But in case of Earth, the origin of Earth's magnetic field is thought to be associated with the electric currents that are produced by coupling of convective currents. They are convective currents that rises inside the Earth's interior, and also the rotation of liquid metallic outer core that is composed of iron and nickel. So on the basis of these two, the Earth's magnetic field is supposed to be originated, and this mechanism is known as dynamo effect, and this results into the Earth's magnetic field. In the end, I would like to request you all that because it takes a lot of efforts in creating these courses, I would like you to please give the course 5-star rating, also review the course, and after that recommend the lessons to your friends on different platforms so that it may eventually help the wider community. In doing this, you will be helping us in spreading the news. So that's all, and thank you and have a nice day. Hello friends, my name is Bhanwar Singh and this crash course on world geography shall be presented by me. In this lesson, we will discuss another topic of physical geography and it is continental drift theory and also seafloor spreading. I have done BA Honours in Law from Awadh University and I am ex-NDA 115 course and I have also cleared Civil Service Examination 2012. My hobbies include writing poetry and you may follow me on an academy platform by following the link that is given on the slide. The continental drift theory was given by German geologist and meteorologist Alfred Wegener in 1915 in his book The Origin of Continents and Oceans. According to this theory, parts of Earth's crust slowly drifts over the liquid mantle and it is supported by fossil records. In brief, there was a gigantic supercontinent which existed about 280 million years ago named Pangaea and it was surrounded by one superocean which was called Panthalassa. Pangaea started to break into small supercontinents named Laurasia and Gondwana land about 150 million years ago, that is during Jurassic period. By the end of Cretaceous period, the continents separated into land masses that look like our modern day continents. As stated, various evidences were put forward to conclude continental drift theory. Firstly, there were certain fossil evidences such as the fossil plant Glossopteris found throughout India, South America, Southern Africa, Australia and Antarctica, and also the fossil of Mesosaurus was found in both South America as well as in South Africa. Secondly, glacier deposits left over from millions of years ago all over the southern hemisphere was also cited as an evidence. And also there was a similarity in rock structure on opposite sides of the Atlantic Ocean. Last but not the least, the important evidence put forward was of jigsaw fit, according to which whole continents seem to fit together into one single big continental mass due to their shapes. For example, South America, especially Brazil, fits into Gulf of Guinea of Africa, Antarctica fits into South Australian coast and Southeastern African coast, and also Northwest Australian coast fits East Indian coast. This figure shows the evidences of fossils found on various continents. For instance, the fossil remains of Cynognathus, a Triassic land reptile which was approximately 3 meters long, was found in South America as well as in Africa. The fossil evidences of Triassic land reptile Lystrosaurus was found in India, in Africa and Antarctica. The fossils of fern Glossopteris, which was discussed in the previous slide, was found in all of the southern continents and shows that they were once joined. Apart from this, the fossil remains of freshwater reptile Mesosaurus was also found in South America and Africa. According to the hypothesis that was put forward by Wegener, the supercontinent which was named Pangaea broke into continents that drove away in two directions, that is equatorward and westward. The movement towards equator was because of the gravitational difference force or centrifugal force and because of the force of buoyancy. The movement towards westward direction was due to the tidal force of sun and moon. The Pangaea separated into Angara land or Laurasia and Gondwana land in the Carboniferous period and the space between the two was filled with water and this water body was known as Tethys Sea. The remnants of Tethys Sea in present day can be seen in the form of Mediterranean Sea. The Laurasia, which was the northern part of Pangaea, it consisted of North America and Greenland on the one hand and Eurasia that was without India and Arabia. The Gondwana land, which was the southern part of the Pangaea, it consisted of Africa with Arabia South America, Australia, Antarctica, and India. So in short, Laurasia was divided into two parts and Gondwana land was divided into five parts. At the time of the separation of these continents, the South Pole was located near Durban, near Natal in South Africa. During the Cretaceous period, eruption took place on Gondwana land, and during this period only, the Indian subcontinent, Madagascar, Australia and Antarctica, they all broke away from it. Similarly, the North America broke away and moved westward due to tidal forces of Sun and the Moon. So here you can see this is before the separation. All the continents were joined together, and after separation they separated into present day form. This is how the continental drift theory occurred. Initially in the Permian period, the whole Pangaea was there, which was surrounded by Panthalassa, the water body. Then in Triassic period, that is around 200 million years ago, it separated into Laurasia and Gondwana land. Then in Jurassic period, separation further occurred. In Cretaceous period, the continents acquired almost the shape of present day continents. And in the present day, you may see the figure that this type of continental arrangement came into being. Seafloor spreading is a process that occurs at mid-oceanic ridges, where new oceanic crust is formed due to volcanic activity and upwelling of magma. This theory explains continental drift theory and it formed the basis for plate tectonics theory. Harry Hess proposed this theory to explain the anomaly in the continental drift theory, which is the movement of continental mass due to tidal force of Sun and the Moon and buoyancy and centrifugal force. In this theory, you may see due to the convective current or the convection current which are formed due to the upwelling of magma, the magma rises upwards and it oozes out from the mid-oceanic ridge, and it is this place where the convective currents forces the two plates, plate 1 and plate 2, into opposite direction, which leads to the spreading of the sea floor. As plate 1 and plate 2 move apart, magma rises, it cools down and solidifies and forms new igneous rocks. This is the seafloor spreading, and this shows a constructive plate boundary, which we will study in the plate tectonics. So I hope that you have understood both the concepts, that is the continental drift theory as well as the seafloor spreading. In the end, I would like to request you that because it takes a lot of efforts in creating these courses and we are not asking too much, I just request you to please rate the courses, give us 5-star ratings, review the courses as you go through them and recommend these courses on different platforms so that it may benefit others also. And in doing this, you may be helping us in spreading the news. So that's all in this lesson, and please be in touch for the next lessons. Hello everyone, and welcome once again to new lesson of Crash Course of World Geography that will be presented by me, Bhanwar Singh. In this lesson, we will study another aspect of physical geography, that is paleomagnetism and plate tectonics. I have done BA Honours in Law from Awadh University and I am ex-NDA 115 course and cleared Civil Service Examination 2012. My hobbies include writing poetry, and you may follow me on an Unacademy platform by following the link that is given on the slide or by searching me by my username, that is Sirohi. Paleomagnetism is the study of record of Earth's magnetic field on the Earth's crust. It is known to us that Earth has a magnetic field due to which compass needle always points towards north magnetic pole. We have studied the phenomena of seafloor spreading in the last lesson. When the molten materials by volcanic activity comes out to the surface of the Earth, the magnetic minerals in the surface cools down, they take an orientation parallel to any external magnetic field present at the time of their cooling. For example, magnetite is one such magnetic mineral which is present in the rocks. The study of the rocks revealed the information about the past behavior of Earth's magnetic field, and it led to the transformation of continental drift theory into plate tectonics. Apart from this, it was made known from various studies that the magnetic pole had apparently moved through time. This can be possible only under two conditions. First, that the Earth has had more than one magnetic pole at various times in the past, or that different continents have moved relative to each other over time. The Earth could not have more than one magnetic poles at various times, so the second condition, that is, different continents have moved relative to each other over a time period, seems possible. Here you can see the aspect of paleomagnetism. As the magma oozes out from the ridges, the mid-oceanic ridges, the magma, it acquires the polarity that is present in the external field at that point of time. So you may see the colored portion is of the normal magnetic polarity, and the white portion that is shown is the reversed magnetic polarity. This figure explains clearly that magnetism of rocks formed changes with the external magnetic field present at that time. This picture depicts the shifting of magnetic north pole and south pole over a period of time, and you can see how it had changed from year 1945 to 2000. So there is obvious shifting of magnetic north pole as well as magnetic south pole over a time period. The most relevant and most important of the theories of geomorphology is plate tectonics. According to this theory, lithosphere, which is the outermost layer of the Earth, is made up of 7 major and many minor plates. These plates include not only the crust but also a part of mantle, and their average thickness is about 100 kilometers. Asthenosphere is the upper part of the mantle, which is in plastic or semi-solid state, and it lies directly below the lithosphere. These plates float over this part of the Earth and move in various directions in processes which is collectively known as plate tectonics. These plates are in constant motion, and it is explained by the analogy of a conveyor belt in constant motion. On the basis of the movement between the plates, these may be of three types, or there may be of three types of plate boundaries, which are divergent plate boundary, convergent plate boundary, and transform plate boundary. As explained, there are 7 major plates, which are North American plate, South American plate, Pacific Ocean plate, Antarctic plate, African plate, European plate, and Indo-Australian plate. Apart from these major plates, there are various minor plates, which includes Caribbean plate, Cocos plate, Nazca plate, Juan de Fuca plate, and Philippine plate, etc. In this figure, you may see all types of major plates and some minor plates. So we have Eurasian plate, Indo-Australian plate, Pacific plate, North American plate, South American plate, Eurasian plate, and African plate. Apart from this, you may see Cocos plate and Nazca plate, which are minor plates. As said earlier, the plate boundaries are of three types. The first is the divergent boundaries, which are present where new crust is generated as the plates move in opposite direction to each other. These plates occur at such places where plates move apart from each other due to rising of mantle convectional currents, which exerts tensile force upon the plates. At the margin of such plate boundaries, new crust is created due to oozing out of magma from the mantle, and hence these plates are also known as constructive plate margins. Block smokers or deep sea winds are examples of kind of volcanic activity which are associated with divergent plate boundaries. The examples of divergent boundaries include Mid-Atlantic Ridge and Great Rift Valley of Africa. Another type of plate boundary is convergent boundaries, which are located where crust is destroyed as one plate moves down under the another and are also known as destructive plate margins. The total area of the earth remains the same, and that is possible only because crust is destroyed at the same rate as it is being created at the divergent boundaries. This type of boundary occurs at such place where plates move towards each other and one plate sinks under the another. Subduction place is the place where two plates, usually an oceanic plate and a continental plate, collides, and one plate, which is in this case oceanic plate, subducts or submerges under the continental plate. The convergent boundaries may occur in three ways. That is, it may occur when one plate is oceanic plate and another is continental plate, that is ocean continental plate. Then when both the plates are oceanic plates and when both the plates are continental plates. The third type of plate boundary is transform boundaries, which are such plate boundaries where crust is neither created nor destroyed because plate slides horizontally past each other. Because the crust is neither created nor destroyed, so these plates are also known as conservative plate margins. This is zone between two plates sliding horizontally past one another, and the large faults or fractures along transform boundaries connect two divergent boundaries, or less commonly convergent boundaries also. Most of such transform faults are found on oceanic floor, however certain are found on the land. For example, San Andreas Fault Zone in California, the Blanco, Mendocino, Murray and Molokai fracture zones. These are the examples of transform boundaries. This figure shows all type of plate boundaries. We have conservative plate boundaries, then the constructive plate boundaries and the destructive plate boundaries. So in convergent plate boundaries, you may see that one plate moves towards the another plate. In the transform plate boundary, they slide past each other, and in the divergent plate boundaries, two plates move in different directions in opposite directions. Plate boundary zones are those boundaries which are not well defined, and because of the plate movement, deformation occurs over a broad belt which is called the plate boundary zone. For example, Mediterranean alpine region between Eurasian and African plate is such place where several smaller fragments of plates have been recognized. Hotspots are such areas which are not usually located on the edges of tectonic plates. These are located above mantle plumes where the temperature of plume causes the crust to melt and form pipes through which magma comes out. The magma plume remains at the same place and the tectonic plate moves, which causes the volcano becoming dormant after some time. A new volcano is formed as the tectonic plate shifts over the hotspot. The example of such hotspots includes Hawaiian Islands, Snake River Plain and India's Deccan Plateau. In the end, I would like to request you that please rate the course, give us 5-star ratings, review the courses and let us know how you are finding this course, and also recommend these courses to others so that it may benefit others also. And in doing this, you will be helping us in spreading the news. So that's all in this lesson, and have a nice time. Hello and very warm welcome to everyone to this crash course of World Geography, which will be presented by me, Bhanwar Singh. In this lesson, continuing our journey of physical geography, we will study mountain building or orogenesis. I have done BA Honours in Law from Awadh University and I am ex-NDA 115 course and cleared Civil Services Examination 2012. My hobbies include writing poetry, and you may follow me on Unacademy platform by following the link that is given on the slide. There are various forces which are responsible for creation, destruction, recreation and maintenance of different types of relief features on Earth crust. On the basis of origin, they can be clubbed into two major heads, that is endogenetic forces or exogenetic forces. Endogenetic forces are such forces which acts from beneath the surface of the earth and are of two kinds, that is sudden or catastrophic, or slow or diastrophic. Exogenetic forces are such forces which act on the surface of the earth and they are of denudational or destructive in nature. Mountains are the significant relief structures of second order on Earth's surface, and generally their height is more than 1000 meters. By the term orogeny, we mean the creation of mountains. It is the primary mechanism of mountain formation, and the mountains are formed by upward and downward displacement of the Earth's crust, which may be due to folding, faulting, or compressional and tensional forces of the Earth's crust. There are orogenic belts, which are mobile belts arranged in linear or arcuate shape and are subjected to severe deformation and resultant mountain building. These belts are generally found near the edges of the continents. Usually, young fold mountain belts are found along continental margins. Many other mountain belts extend to the ocean and they abruptly terminate at the continental margins. Various theories have been put forward to explain the process of mountain building, and the prominent among them are geosynclinal theory, which was put forward by Kober, thermal convectional current theory put forward by Holmes, radioactive theory by Joly, continental drift theory, which we have studied in the last lesson by Wigner in the previous lesson, and in the last lesson we have studied the plate tectonic theory that was given by a bunch of geographers, Harry Hess, Mackenzie, Parker and Morgan. The mountains on the basis of orogeny may be clubbed into fold mountains, block mountains, volcanic mountains and relict mountains. The fold mountains are formed when a thickly bedded sedimentary layer is subjected to endogenetic horizontal compressional forces for a long period of time. The sediments then bend into up and down folds, as you may see here, up and down folds, which later develops into anticlines and synclines respectively. So the up fold are known as anticlines and the down folds are known as synclines. In such mountains, folds are arranged in wave-like pattern. These are the highest and extensive mountains of the earth. These mountains are further classified into young fold mountains and old fold mountains on the basis of the time period of their formation, and the example of fold mountains are Himalayas, Alps, Atlas, Andes, Ural, etc. Second type of mountains are block mountains, which are formed due to endogenetic tensional force which leads to creation of rift valley. Block mountain or horst is the upstanding part of the ground between two faults on either side of the rift valley or a graben. So as you may see here, this is the upward part, that is standing part, which is known as block mountain. Then we have a rift valley and the fault lines that lies in such kind of arrangement. The example of block mountains include Vosges in France, Black Forest in Germany, Sierra Nevada in North America, and Satpura and Vindhyan ranges in India. The third type of mountains are the volcanic mountains, which are formed due to continuous deposition of lava, which leads to formation of a conical peak. The example of such volcanic mountains include Mauna Kea in Hawaii, Fujiyama in Japan, and Cotopaxi in Ecuador. Relict mountains are not the original mountains, but these are formed when original mountains are eroded by agents of degradation, and after that they become relict or residual mountains. The example of such relict mountains include Aravallis, Eastern Ghat and Vindhyan ranges in India. On the basis of time period of formation, mountains are again classified into four types. The first are the Precambrian mountains, which are the most ancient mountains formed before the Cambrian period. Due to the excessive weathering and erosion, these are now relict mountains, and the example of Precambrian mountains include Laurentian Shield of USA, Northwest Highlands of Europe, etc. The Caledonian Mountains are the second type of mountains on the basis of period of their origin. These are formed during Cambrian, Silurian and Devonian periods of Paleozoic era, and they are named after Caledonia, mountains of Scotland. The example of such Caledonian mountains include Scandinavian mountains, Vindhyachal, Satpura and Aravalli mountains of India. The third type of mountains on the basis of period of their origin is the Hertzian mountains, which are formed during Permian or Triassic period, and they are named after Harz mountains of Germany. The example of such mountains include Appalachian mountains, Spanish Meseta, Brittany of France, Vosges and Black Forest. Alpine mountains are the young mountains and they were formed in Cenozoic era and Tertiary period. Hence, they are also known as Tertiary mountains and named after Alps mountains of Europe. The example of alpine mountains include Rockies, Andes, Alps, Atlas, Himalayas and the Great Dividing Range of Australia, etc. There are some terms which we frequently encounter while studying mountain. For example, mountain range, which is a system of mountains and hills having several ridges, peaks and valleys, and it is formed in a particular period spreaded in narrow belt. The mountain chain is a system of several parallel, long and narrow mountain ranges formed in different time period. A mountain group consists of several systematic patterns of different mountain systems with a proper arrangement. The mountain system consists of different mountain ranges of same period. And a mountain ridge is a system of long, narrow and high hills usually formed on oceanic crust. Here is the list of certain important mountain ranges, which includes Rockies in North America, Tian Shan in South Central Asia, Altai in Central Asia, Ural in Central Russia, Kamchatka in Eastern Russia, Zagros located in Iran, Elbrus is also located in Iran, Caucasus in South Europe and Apennine in Italy. So this is all in the mountain formation and about the mountains, and I hope you have understood the lesson. In the last, I would like to request you to please rate the courses, give us 5-star rating and also review the courses and let us know how you are finding the lessons and the course. And please recommend these lessons and courses on different social media and platforms so that it may benefit others also in their studies as well as in enhancing their knowledge. That's all and have a nice time. Hello everyone and welcome to the crash course on World Geography. I, Bhanwar Singh, shall be presenting this course to you. The topic for this lesson has been chosen from physical geography, that will be earthquakes and volcanoes. I have done BA Honours in Law from Awadh University and I am ex-NDA 115 course, and also I have cleared Civil Services Examination 2012. My hobbies include writing poetry and you may follow me on Unacademy platform by following the link that is given on the slide. Earthquake is shaking or vibration of earth crust. The point from where the earthquake originates, which lies inside the earth crust, is called focus of the earthquake. The point that is perpendicular above the focus on the surface of the earth where earthquake is experienced for the first time is called the epicenter. There are two kinds of lines that joins the places which experiences earthquakes. First one are called isoseismal lines, which joins the places of same seismic intensity, and the second one are homoseismal lines, which joins the places which experiences the earthquake at the same time. There are certain areas on the Earth's surface which do not experience the effects of P and S waves, and these areas are known as shadow zones. It is interesting to note that before earthquake strikes a place, the amount of radon gas increases in the atmosphere of that region. The earthquake can be caused by various factors and it may range from tectonic process, the sudden movement of crustal blocks along fault lines, or it may be caused due to volcanic eruption or anthropogenic disturbance of isostatic balance of earth crust. Isostatic balance is the natural balance of the earth that it maintains, and if that is disturbed by the human action, then it may cause the earthquakes. Then we have the water pressure, as it may be experienced in case of dams which are located on the fault lines, and also the contraction of earth's surface and the expansion of gases beneath the surface of the earth may be a cause of the earthquake. During an earthquake, there are certain waves which are produced and are recorded by an instrument that is known as seismograph. These waves have also been very helpful in determining the internal structure of the earth. There are two types of waves that originate during an earthquake, and they can be broadly classified into body waves and surface waves. The body waves are those waves which originate from the focus and they travel inside the earth's surface. These waves can be classified into two, that is the primary waves or P waves and the secondary waves or S waves. Then we have surface waves, which are those waves which are experienced on only the surface of the earth, and it is only of one type, that is L wave. So there are in total three types of waves, that is P waves, S waves and L waves. These waves are different in their characteristics. For instance, P waves or primary waves are also known as longitudinal waves, and these are analogous to sound waves. P waves are the fastest moving waves, and thus they are the first ones which are recorded by seismograph. And the one characteristic of these waves is that it can travel through solid as well as liquid medium. The second wave or the S wave and the secondary waves are also known as the transverse waves, and these are analogous to light waves. They have intermediate speed between primary waves and surface waves, and they cannot travel through liquid medium. The surface wave or L waves are analogous to water waves, and they originate from epicenter and not the focus. These are the most destructive of all types of seismic waves, and they have the least speed of them. So here you can see how the P, S and L wave are recorded by seismograph, and you may see that P wave have the highest frequency while the L wave have the lowest frequency. In this figure you may see how a particular wave travel inside the earth crust. You may see the P waves, which are depicted by the pink lines that travel through the outer core, which is in liquid state. You may see here. And the S waves, which do not travel through the outer core, and the S waves are depicted by the green lines. On the surface of the earth, there are places which do not record P wave, which is known as P shadow zone, and it lies from 105 degree to 145 degree from the epicenter. There are similar regions which do not record S waves, and these are known as S shadow zone, and it is the entire zone from 105 degree from the epicenter. Next, moving forward, we will study about volcanoes. A volcano is a vent or opening which is usually circular or nearly circular in form in the earth crust, through which molten magma, gases, water vapor and fragments of rocks erupt suddenly. Volcanism or volcanicity includes all the phenomena that is associated with volcanic eruption, right from movement of magma to getting it cooled in various forms, either on the surface of the earth or beneath it. Magma oozes out during a volcanic activity, and it is the molten silicate material that is combination of solid, liquid and gaseous mixture. Magma is of two types, that is basaltic, which is fluidic or it is less viscous, and granitic, which is highly viscous. The volcanoes have been classified on two bases, that is on the basis of activity and of eruption type. According to the basis of activity, the volcanoes have been clubbed into three types, that is active volcano, which are such volcanoes which constantly eject volcanic lava, gases and ashes. Then we have dormant volcanoes, which are those volcanoes which were active in past, but for several years they have not shown any kind of activity. Dead or extinct volcanoes are such volcanoes which have not shown any activity since a long period of time, which ranges in thousands of years. On the basis of eruption, the volcanoes have been classified into two major types, that is fissure eruption and central eruption. Fissure eruption is the quiet eruption type where large quantities of lava flows from fissure and spreads over surrounding areas. Mainly here the lava is basaltic, and then we have central eruption where magma comes out with great pressure through small vent, and it is again classified into Hawaiian type, Strombolian type, Vulcanian type, Vesuvian type, Plinian type and Palean type. These types are based upon the explosion, and in Hawaiian type there is no explosion, and while moving towards Palean type the explosion it occurs in higher frequencies. So Hawaiian type has no explosion, then we have higher explosion in Strombolian, that is small explosion. Vulcanian type have more explosion than Strombolian, and so on. And the lava, it turns from basaltic lava from Hawaiian to Palean type, the lava becomes more granitic. The volcanic eruption leads to formation of various relief features both inside the Earth's surface as well as over the Earth's surface. When they are formed beneath the surface of the Earth, they are called intrusive volcanic relief structure. As can be seen in the figure, various landforms are created. A dike is a shaft of igneous rocks that cut across the geological layers. Sill or sheet, it runs parallel to the geological strata. A laccolith is formed and it is a larger intrusion that causes rock above to form domes, and it is dome shaped. A phacolith is intrusive a volcanic structure that is parallel to bedding plane or folded inclines. A large saucer-shaped intrusion of igneous rocks is known as lopolith, which is found parallel to depression or synclines. Batholith is very large mass of intrusive igneous rock that forms and cools deep inside the Earth's crust. The volcanic topography is again divided into two parts according to the depth. Those which are found just below the Earth's surface are known as hyperbasal, and those which are formed deep beneath the surface of the Earth are called plutonic. The relief features by volcanic eruption which are formed on the surface of the Earth are known as extrusive volcanic relief features. These are flood basalts, which are result of giant volcanic eruption and coats large stretches of land and or oceanic floor with basaltic lava. Then we have shield volcanoes, which is a broad domed volcano with gently sloping sides which is formed due to basaltic lava which has higher liquidity. Then we have ash or cinder cone, which is deposit around a volcanic vent formed by pyroclastic rock fragments and accumulation into a conical hill. They generally develop from explosive eruptions. Then we have parasitic cone, which is accumulation of volcanic material on side of main cone. This type of cone is more frequent in case of acidic lava. Then we have crater, which is mouth of the volcano, and the enlarged crater is known as caldera. Then hot springs, geysers and fumaroles are also formed. Hello everyone and welcome to the crash course of World Geography, a course that has been designed by me, Bhanwar Singh. In this lesson, we will study another topic of physical geography, which is rocks, weathering and erosion. I have done BA Honours in Law from our university, and I am ex-NDA 115 course and also cleared Civil Service Examination 2012. My hobbies include writing poetry, and you may follow me on an Academy platform by following the link that is given on the slide. Rocks are composed of various minerals and elements. There are more than 100 elements which are found on the Earth crust, and out of them only 8 are major rock forming minerals, and they constitute about 98% of the Earth crust. In decreasing percentage of order, these elements are oxygen, silicon, aluminium, iron, then calcium, sodium, potassium and magnesium. The number of minerals found on Earth crust is more than 2000, and out of these 2000 minerals, 24 minerals are called rock forming minerals. Out of these 24 minerals, 6 minerals are found in large amount and large quantities, which includes feldspar, quartz, pyroxene, amphiboles, mica and olivine. The rocks are of three types on the basis of their mode of origin, that is, igneous rocks, sedimentary rocks, metamorphic rocks. Igneous rocks are also known as primary or basic rocks. These are formed due to cooling and solidification of molten magma. These rocks are granular and crystalline, and no layers are found in these rocks. Therefore, no fossils exist in igneous rocks. Igneous rocks can occur in two ways, either on the surface of the earth, which are known as extrusive igneous rocks, or within the crust, which are known as intrusive igneous rocks. The intrusive igneous rocks are coarse, whereas the extrusive igneous rocks are fine-grained because the rocks get cooled slowly inside the Earth's interior due to high temperature. On the basis of mineral and chemical composition, the igneous rocks may be classified into felsic, mafic or ultramafic rocks. Felsic rocks are those igneous rocks which have higher silica content. Mafic rocks are those igneous rocks which have low silica content, and the ultramafic rocks are those igneous rocks which are intermediate rocks. Black soil, which is also known as regur, is formed from igneous rocks. Next type of rocks are the sedimentary rocks, which are formed on the surface of the earth due to erosion and deposition of igneous and metamorphic rocks. These rocks are found over about 95% area of the earth's crust, but they contributed only 5% during the formation of the crust. These rocks contain fossils and are layered or stratified rocks. Thus, these rocks also contains rich reserves of petroleum and natural gas. The sedimentary rocks can be classified into three groups on the basis of the nature of sediments. That is, first is mechanically formed sedimentary rocks, which includes sandstone, conglomerates, clay, etc. Then we have organically formed sedimentary rocks, which includes limestone, coal, peat, etc. And the third one are the chemically formed sedimentary rocks, which includes chalk, gypsum, salt rock, etc. Metamorphic rocks are the third type of rocks found over the surface of the earth, and they are formed due to intense heat and pressure. This results into complete change in appearance and constituent of parent rock due to change in mineral composition and texture. Metamorphic rocks are formed from sedimentary, igneous and metamorphic rocks, and these are the hardest rocks and they do not contain any fossils. The example of metamorphic rocks includes slate, which is formed from shale and clay. Then we have quartzite, which gets formed from sandstone and conglomerate. Then we have gneiss, which is formed from granite, schist, which is formed from phyllite, amphibolites and schist, which are formed from basalt. Marble is formed when limestone, chalk or dolomite undergoes metamorphosis. Phyllite is formed from slate. Serpentine is formed from gabbro. Here you may see how rocks transform into either of three types. The sedimentary rocks, upon melting, they convert into magma, which upon crystallization forms igneous rocks. Igneous rocks on erosion, transportation and deposition changes into sedimentary rocks, and under intense heat and pressure changes into metamorphic rock. Metamorphic rock again upon melting and crystallization changes to igneous rock, or under erosion, transportation and deposition changes into sedimentary rock. Sedimentary rock in turn upon intense heat and pressure changes into metamorphic rock. This transformation of a particular type of rock into another types is known as rock cycle. There are certain forces which act from inside the earth crust and others which act over the surface of the earth. The exogenetic forces are such forces which shape the earth's surface by acting on or above the surface of the earth. The main function of exogenetic forces is denudation. Denudation is the combination of processes that cause the wearing away of Earth's surface by a general lowering and leveling out of the surface. Denudation includes two main processes, that is, weathering and erosion. Weathering is the breakdown and alteration of rocks and minerals at or near the surface of the earth into smaller parts. It is the first step for a number of biogeochemical and geomorphic processes, and weathering also contributes to soil formation. Erosion is large-scale transportation of weathered rocks and minerals. So basically the difference between weathering and erosion is that erosion involves transportation, whereas weathering do not. There are certain factors which are responsible for weathering, which are: first is the type of rock and its structure. Hard rocks are less susceptible to weather than soft rocks. Second is the temperature, which also affects the rate of weathering, and last but not the least, water and organisms also helps in accelerating the rate of weathering considerably. The weathering on the basis of its agents may be classified into chemical weathering, which includes weathering by solution, oxidation, hydrolysis, hydration and carbonation; physical weathering, which includes weathering by abrasion, collision, crystallization and insolation; and biological weathering, which includes weathering due to breakdown, mixing, or due to respiration by organisms. So that's all in this lesson, and in the end I would like to request you to please rate the courses, rate this course, give us 5-star rating, review the course as you go through it, and let us know if you are liking the course, and also recommend these courses on different platforms so that it may benefit others also. That's all, and have a nice day. Thank you. Hello everyone, my name is Bhanwar Singh and I welcome you all to the crash course of World Geography. This is yet another lesson from Physical Geography which will cover the fluvial and glacial landforms. A river works by three ways: first by erosion, then by transportation, and lastly by deposition of transported materials. Erosion by river depends upon size of load and its caliber, and also upon velocity of the river and channel gradient. This is the reason why erosional work of the river is more in its youthful stage than in the old stage. Velocity of the river also depends upon the slope and volume of the water. Landforms by river are created in two ways: by its erosional work and by its depositional work. The erosional landforms formed by erosional work of river includes: first, V-shaped valley. This is mainly created in its youthful stage when a river flows through steep slopes. For instance, Indus River has cut across the Himalayan ranges and flows through 17,000 feet deep gorge and canyon. The V-shaped valley in its mature stage converts to gorge. For example, Hundrugad Gorge on Subarnrekha near Ranchi, and in its old stage it converts into canyon. Grand Canyon of Colorado River in Arizona is one such example. Second landform is waterfall, which may be created due to three reasons. Number one, due to arrangement of hard rocks and soft rocks horizontally, where soft rock gets eroded and stream falls from a height, creating a waterfall. An example of such waterfall is Great Fall of Yellowstone River in USA. Number two is when the hard rocks and soft rocks are arranged vertically, where once again soft rocks get eroded more than hard rocks and led to creation of waterfall. Niagara Fall in Rewa, Madhya Pradesh is one such waterfall. Number three, due to either upliftment of the landmass or its subsidence, due to which river water falls and it creates a waterfall. Garsoppa Falls or Jog Falls are believed to be formed by upliftment of landmass. When waterfalls are small, then it is known as rapids, and when rapids are arranged in a series, they are called cascade. Water, when it falls from waterfall, sometimes creates a depression which is known as plunge pool. Next type of landform created are structural benches. These are created due to linear arrangement of hard rocks and soft rocks. And also terraces are formed, which are elongated terraces that flank the sides of floodplains and are remnants of earlier floodplains. Potholes are created in the bed of river due to its erosional work, and many potholes are found in the rivers which drain Chota Nagpur Plateau. Meander River of Asia Minor flows through numerous beds, and this is the reason why the flow of river in serpentine way came to be known as meandering. Gomti River is the typical example of high meandering stream due to low channel gradient. Oxbow Lake are created due to meanders. Its numerous examples are found in Pratapgarh district of Uttar Pradesh. This figure depicts how meandering occurs and is also responsible for formation of Oxbow Lake. In a meander, we have two slopes, undercut slope and slip-off slope. When river moves in meander, the velocity of river is high in the outside part or the undercut slope, and it is lowest in the inner part or the slip-off slope. This leads to erosion of undercut slope and deposition of silt at the slip-off slope. When this continues for quite some time, river changes its course and a horseshoe-shaped lake is cut off, which is known as Oxbow Lake. River creates many depositional landforms. For example, it creates natural levees, which are elevated partitions between channels and floodplains. Alluvial cones and alluvial fan are also formed in such regions where sudden fall in slope angle occurs. This leads to deposition of heavy boulders at the foothills of mountains or hills, which take either shape of cone or fans, and as such are called alluvial cones and alluvial fans. Alluvial plain are also produced by river by deposition of silt and sediments over the plains. These are very fertile plains and the population density at such plains is generally high. Deltas are created by river at its mouth due to deposition of sediments. It increases towards sea every year, and it could be of various shapes such as arcuate delta, which is typical triangular delta found at the mouth of Nile River, Irrawaddy River, Danube River, Indus River, or it could be birdfoot delta, which is found at the mouth of Mississippi River. Cuspate delta is formed when sediments brought by river are spread on both sides of its mouth by the action of waves. For example, Tiber River in Italy makes such delta. Estuary is formed when mouth of river gets submerged, and due to this, it does not make any delta. For example, Seine in France and Narmada and Tapti in India forms estuaries. Next, we will discuss the glacial landforms. Glaciers are slowly moving mass or river of ice which is formed due to gathering and compaction of snow on mountain peaks or near the poles. Height of glacier decreases towards poles from equator, and there are glaciers over all the continents except Australia. Snow line gets maximum affected by the climate. The glacier also creates landforms either by erosional work or by deposition. Erosional landforms created by glacier includes U-shaped valley, which is created by process of glaciation and have characteristic U shape with steep straight sides and flat bottom. Next is hanging valley, which is a tributary valley higher than the main valley and is formed due to different rates of erosion of main valley and the tributary valley. Cirque is an armchair-like structure produced by glacier due to erosion. It is known by different names in different countries. For example, Corrie in Scotland, CWM in Wales, Carr in Australia, Nish in Sweden, and Jadel in Scandinavia. Berggrund is created and is a crevasse that forms when moving glacier separates it from main ice column. Tarn is a pit-like structure created by glaciers. It is produced at foothills regions of any mountain and converts into Tarn Lake in summer season when the ice of Tarn melts. When more than one cirque exists on both the sides, and this is depicted as a comb, or when cirques are displaced towards each other on both sides, the middle part becomes pointed after erosion, which is called arete. Horn is the middle part of the glacier, which gets converted into standing sharp structure due to erosion from all sides. Apart from this, when the glacier moves downward along the slope and fjord region, the slope gets converted into terrace-like structure, which is called ice terrace. Roche Mountain is formed when during the movement in the valley, if hard rock appears in the way of glacier, it makes gentle slope on one side, and on the other side it erases soft rock particles, and this structure looks like back of the sheep. While moving over hard rocks and soft rocks arranged horizontally, the glacier erodes soft rock, but the middle part of hard rock keeps standing, which is known as crag, and the remaining eroded soft rock is known as tail. Glaciers also, like river, creates depositional landforms. It creates moraines, which are depositional plains formed due to glaciers by accumulation of unconsolidated glacial debris. On the basis of location with respect to glacier, it may be lateral moraine or medial moraine or terminal moraine or the ground moraines. Drumlin is another landform created by depositional work of glacier. It is elongated teardrop shaped hills of rock, sand and gravel formed under moving glacier. Eskers are long, very narrow ridge, often in meander form, is composed of stratified sediment and marks the former location of a glacial tunnel. Another depositional landform of glaciers is kettle. These are big depressions by glacier mainly near snow line. The particles, which are made up of hard rocks and are not eroded, makes dune-like structure which are called hammock. So that's all in this lesson, and here you may see the glacial landforms. We have the cirques, horn, arete, medial moraine, main glacier and truncated spurs. So that's all in this lesson of fluvial and glacial landforms, and in the end I would like to request you to please give us 5-star rating, review the courses and also recommend these courses on different platforms so that it may benefit others also. So that's all for this lesson, and have a nice time. Thank you. Hello everyone, my name is Bhanwar Singh and I welcome you all to the crash course on World Geography. The topic of this lesson has been chosen from physical geography, and we shall study the marine, arid and karst landforms in this lesson. In the oceanic region, the rate of erosion depends upon the velocity and length of waves, types of rocks, time and instruments of erosion and slope of the coast. The sea waves carries out erosional work that creates a number of landforms. It includes coastal cliff, which is formed by erosive power of the waves at its base. As the sea cliff grows landwards, a crack or gap develops in the roof of cave from where air passes. This gap is converted into hole-like structure which is called blowhole. An inlet develops along the coastal region, which is notch of a shoreline, usually long and narrow, which often leads to an enclosed body such as lagoon, bay, etc. Another characteristic feature of erosional work of sea waves is a wave-cut platform, which is narrow flat area often found at the base of a sea cliff. They are visible during low tides. A gently sloping coastal feature or at the seaward side of wave-cut platform is formed by sedimentation in the deeper water on the continental shelf, which is known as wave-built terrace. A natural arc is usually narrow bridge walled by cliffs. Sea stack consists of steep and vertical column or columns of rocks in the sea near coastal areas formed due to erosion work of oceanic waves. Another landform created is coves or lagoon. This is a stretch of salt water which is separated from the sea by a low sandbank or coral reef. The sea waves also do depositional work which creates depositional landforms. Bar is a ridge-like structure formed by deposition of waves. Bar remains above water due to its height and barrier remains below the sea water. Offshore barrier is parallel to coastal area and away from the coast. A spit is a tongue-like structure whose one part is attached to the coast and another part is in the sea. Tombolo is a deposition landform by sea in which an island is attached to the mainland by a narrow piece of land such as a spit or bar. Beach is a beautiful and popular landform formed by fine sand particles deposited by low and high tides. When its shape is semilunar, it is called a cusp beach or semilunar beach. For example, Miami Beach in Florida and Kovalam Beach in Kerala. Next, we will study the arid landforms formed by erosional work of winds in desert. It depends upon velocity of wind, amount of sand, dust particles and its nature, structure of the rocks and climate. There may be erosion either through the action of wind or air or through sudden rainfall. A blowhole is formed when the soft rocks are eroded by the air. Demolition is formed when the hard rock lies on the top of soft rocks and the soft rock gets eroded fast, leaving the stacks of hard rocks. An Inselberg is formed due to erosion of soft rocks, and it is an isolated hill or mountain that rises abruptly from a plain surface. Mushroom is another example of erosional structure built by action of winds. In the upper part of atmosphere, the wind velocity high, and in lower part near the ground it is low. The wind velocity is high in mid region too. However, instruments of erosion are less in the upper part of atmosphere, and the instruments of erosion are greater in both middle part and lower part. This results in differential erosion of the surface of the rock, which turns it into mushroom-like structure. Zeugen and Yardang are another relief structure formed due to alignment of hard rocks and soft rocks. In Zeugen, they lie horizontally, and in Yardang, they lie vertically. A decanter is a type of a ventifact that forms due to abrasive action of blowing sand. Balsam is the landform created by the action of rainfall in desert areas. Pediment are the eroded hills in desert due to rainwater. Bajada is sediment deposited, and Palaya is a lake formed in between the pediments. The depositional landforms of wind and arid zone contain sand dunes, which is a hill of loose sand built primarily by wind, where the shape of sand dune is crescent shape. It is as found in desert as known as Barchan. Seef are small sized dunes. Gasi is depositional plane or depositional structure which exists in between sand dune, and it is sand free zone where no sand dune structure is formed. Lewis plain is formed when sand gets accumulated in any plain through wind. It was first seen in southern France. Karst landforms are such landforms which are formed due to dissolution of soluble rocks such as limestone, dolomite and gypsum. Lapis are weathered surface found in karst regions, and it consists of rugged, fluted rock pinnacle separated by deep grooves. A hole or depression is formed in the ground due to some form of collapse of the surface layer due to chemical dissolution of carbonate rocks. These are known by different names on the basis of their size. The smallest is hole, and then we have sinkhole, then swallow hole, and then comes dolime, and then uvala. Many uvala combines to form polgy. Polgy is a large flat plain depression found in karst regions. Several sinkholes merge to create a bigger and larger depression, which is known as solution valley. River flowing in a limestone region are dried within its basin. This is because of deep faults lying in its course. These faults draw water from the rivers and supply the underground areas with it. These faults are sinking creeks. Caves or solution caves are formed in karst region. Rock is dissolved by groundwater that seeps through bedding plains and faults. The underground water in karst region also produce some depositional landforms, generally inside the cave. A tapering structure that hangs from the roof of a cave is known as stalactite. The corresponding formation on the floor of the roof, floor of the cave is known as stalagmite, which is formed when the soluble colloid from stalactite drops over the floor of the cave. When both landforms of stalactite and stalagmite they meet each other tip to tip. It is known as cave pillar. So that's all in this lesson of the landforms, and I hope that you have understood all the kind of landforms that are found in marine, arid and karst regions. In the end, I would like to request you that because it takes a lots of efforts in creating these courses, and we are working all over the round time to create these courses which are very helpful and useful to you. So please rate the courses, please give us 5-star rating, review the courses, and also recommend these courses on different platforms so that it may benefit others also. So that's all in this lesson, and have a nice day. Thank you.